Okay, so um, let's open our data acquisition project and see what we do next. Okay. So as you as you remember, the last time we have been improving on our device architecture, also on our device factory, and we mentioned that there might be one improvement we can do. That is because currently the way it works is when we create a factory, then in the constructor of every individual factory, where was it? Let's go to the demo device. There we set this variable which allows us to reference the factory from our device object. And in case we would create multiple factories, that would be a bit inconsistent because only one of them would be actually pointing to will be pointed to. So we can today improve that introducing a design pattern called a soliton, which allows us to create objects of which always there should only be one instance at any point in time, and the way this is implemented ensures it that the user cannot accidentally create a second instance. So how do we do that? First, let's close most of the things that we don't need right now and take a look. So here in our factory we will move the constructor and the destructor to the protected section so that they cannot be called we will do only in the child classes, otherwise this will not work. Let's start with the demo device right here. So as mentioned, we move the constructor to the to a protected section. So here as you see, we already are not able to access this, so what we need will be a function that will allow us to in some point create an instance. So what we do, we just create a function called get instance and what this function will do is it will use our static variable. We can remove this from here currently. It will check if this is not null, so if our static variable exists. So if we already have created a factory, then we return it. Otherwise, let's see what is demo device. Device is here, right? We need factory class that should be accessible. 1 second. Right, instance must be static, of course. That's one thing. Want that to be static, and it's complaining. This one is static already. Demo device factory. Right. Okay, but that should be castable as well. Right. And we can change this to the right type. Static class device factory. Okay, so we check whether it already is instantiated, and if it is, return it. If it is not, then we create a new instance, and only from here we can call the constructor. Demo device. That should be fine. Factory is a friend class. That's a it should be fine. And once we're done with creating, we just return it. Why that is actually complaining, that's actually quite strange. Let's quickly build it. this is for because it doesn't know the other type. It's a pointer, so we can always cast that. That's one thing. Oh, I have a typo. Yeah, the epsilon was missing. Right, and we have changed here the type to this, although it's more elegant to leave this as it was. Leave this as it was here and change it. Here it will need a change. So we can improve this slightly. We check if it's not defined, then we define it. Now the code of course has one case where this will not work perfectly. Oops, that was a copy and paste bug. The situation where the code will not work as it should is if we have multiple threads, because then we don't have a guarantee when the thing will so if we enter this function, this get instance, while there isn't an instance from two threads at the very same time, then this would then still potentially cause the creation of two objects, and very likely in the end only one of the two objects would end up being used. We could protect against it using a mutex, but since this whole thing here is only single threaded, we will not do that. What we now need to do is to propagate this change to our other devices, and then of course to use this in the proper way. So for the TCP device we do the same thing. Okay, that should be on. Then I'll go of course the same for test device. Alright, and we need to remove that since we already set this. So here this goes away as well. Right, the test device. There we of course need to change this and this and this and the other things accordingly. Okay. Right, so now when we try to compile the project, we'll run into the error that this cannot be accessed, so we'll fix that next, but just so that we can quickly find where it is. We forgot something. Demo device, TCP device, yeah. I forgot to change this here, okay. Okay, so now we have the 3 expected errors, and here instead of new this, we just use get instance. What here? And it is present, so it should be fine. Public it as well. Oh yeah, I another copy and paste back. No, it should be fine. Yeah, copy and paste is dangerous. It's easy to do something wrong. Okay, so this is one improvement, and generally such approaches where you create constraints on how your code is allowed to work is somewhat useful, because it allows you to ensure that later on the code will be forced to be maintained in a clean way. So usually what people like to do often is that they somewhat just program as it's convenient, and then the code becomes very entangled and intertwined, so that when you later on need to make a large change, then this becomes difficult, and of course this also limits the testability of the code. So ideally, if you would want to work in a large setting with hundreds of other developers, then it's not really practical to test everything each time something gets changed. So what you would want is you would want to implement a lot of unit testings, so that individual portions of the code can be tested synthetically once they are changed, and that you have to a certain degree some certainty that parts of the code will not influence other parts that you are not working on. And separating your project in multiple individual parts is one of the steps. An approach another design pattern often taken is to create abstract interfaces. We did that to some extent here with our device class. Technically, this is not an abstract interface because it has implementation. So we have here name and parameters which are already kept on the parent object, plus the thing is derived from a Q object, which itself is not an abstract interface. But in principle, if the goal would be to create something that is interoperable in to a high degree, then one of the things that one could do is to use as interfaces only classes where every single function is virtual and abstract, so like the one here, for example, like the get factory, and then have the implementations individually made in all the derived classes. And the way this works is that it would allow you to create, for example, binary plugins, and as long as you don't change the interface definition, no matter what you change about the actual implementation class, some project compiled long time ago, as long as it was compiled for this version of the interface, will remain compatible. What you can also do without breaking compatibility is adding additional functions at the bottom. So the functions, so effectively, if you would have a fully abstract class, we can maybe create a small demo project for that. Create new project. We just go with a normal console application. And we can be quick, so we won't make any header, so we just make class see my interface. Let's say set name this should be enough. And let's include a few more things. And if you really want to maintain the maximum level of interoperability with your interfaces, then you should only use either machine types or your own or pointers to other of your own objects which you have created as an interface. So, for example, for set name, let's just use const chat asterisk name, as this is a C string, so it always works. Of course, it's not super secure, but it works. And then, of course, for getting the name, you would do the same const get name, and the get it's a const function. And at this point, the whole thing is just a jump table, so it does not contain anything of its own. So we will need some implementation. So class my implementation one. Of course, this thing needs a constructor. And already one thing which complicates things a bit is that here we would like potentially to be able to get rid of the object. So as long as we only work, of course, with our own type, then we can easily destroy it. But here, what we could do is we could create a virtual destructor that will ensure that it will be called. But the thing cannot be fully virtual, so it cannot be abstract. It can be virtual, but cannot be abstract. So it kind of already breaks the pattern a little bit. So what one would do instead, since we really don't want any code here, is we would implement a custom release function or free or however you want to call it. Right? Delete me, for example, which is null. And then while we here can have a normal destructor, inside the function would actually use it. Delete me would then just call delete this. Okay. Alright, and here then we can of course do something. We will need implementation for those two functions as well. Then we need some code. So this one is trivial. We can just return a pointer on the internal thing that we have. For the set, it's a bit more difficult because we need to allocate new memory. So first, we can clear the old memory. Also, we need to do this in our destructor as well. Then we need to allocate it. Oh, I forgot the asterisk here. It might complain that it's not safe. Destination is and source is RP name. Just for completeness, let's this. Okay. And now basically in your main application you would just have the interface, and in some DLL that is loaded you would have the implementation. And even if a lot of changes about your implementation, so you, for example, you switch to a completely different, or at least a completely different compiler would even work, like from Visual Studio to GCC or something, or just if you in the past, if you were switching between major versions of Visual Studio, that also generated incompatible code. Since 2015, this is no longer the case. They now use a unified runtime so that the code remains binary compatible, which is quite nice. But the whole idea is that your interface is only made up of a jump table, and the format of the jump table is standardized. So it will only know where the functions go, and everything else will then be your own to implement. So let's create some demo function. Or let's create function function printing name. And this one takes just a pointer to the interface, for example. And can have some other function that will be setting. So functions setting, then make an interface set name. And the nice thing is that those functions have completely no understanding of how this internally works. So now of course we'll need to create such an object. So implementation is new this, and then we can first we need to set, then we can we could break this up into individual files to demonstrate it even more in detail, and once we have what's done, then we can just delete the thing and it should be gone. So we can put a breakpoint here on the destructor and run it. So as you see, we arrive at the destructor and the whole thing works just fine. And to demonstrate that with really putting it in different files, we can add some we call it plugin CPP. That will be the thing that implements our thing, but we'll need to add some shared header. So headers add interface h. So of course the interface would need to contain this. Okay, and now in our main thing here, where we need to include interface. And we will of course need a way to create the function. So usually in the plugin would export just one single function which creates such a thing. Make my implementation one. Of course the type would then be say interface, since we want to only use the generic specifications, and this thing would then need to be in the header so that it's accessible. So for simplicity we just put the definition here of the thing, and voila, we have a code which is completely oblivious to how this my implementation thing works internally, and it will of course still work because we just reshuffled. Maybe I forgot something. Oh, how did this happen? Yeah. As you see, it still works. So are you interested? Because one of you inquired about different design patterns today morning, so I thought I will make this small detour in showing you how to make a Soliton and how to properly use abstract interfaces, which are quite useful. Do you want to see this project work in its whole glory, like with a real DLL that it loads and so on, or is that not so interesting to you? Okay, so let's add a new project. Windows, but not Qt, all projects. Let's use the search thingy, DLL. I think this one will be the clean one. Like, one of them is the good one, and the other one gives you like a lot of boilerplate code from Microsoft, which we don't need. But I never remember which one is which, and we will call it plugin one. Create. Yeah, that's the good one. It only has the main function, and I think it actually has It has a function in the class. Okay, that it gives us some boilerplate code, but it's fine. Let's just comment out the things we don't need. Okay. So in Windows project, the executable always starts, as you remember, certainly in the main function. And of the main function, there are a few variants how it can be defined. It can be such that you can have arguments, and you can select whether you want to have ASCII characters or white characters. And then there's also a Windows-specific wmain function, which gives you a few parameters for the application, how it should be created. But this is all mostly very similar. For DLLs, it is slightly different. You have this DLL main, and the main reason why this is different is that this DLL main is not just called once, but it's called multiple times. So as you see here, you have a module handler, which will be a pointer to the current instance of the DLL. You will have a reason, which is used here in the switch, and you have a reserved parameter, which Microsoft invented some time ago, and they never found the actual use for it, apparently. And this reason, as you see here, there are 4 reasons when this main is called. First, it's called process attach, when a DLL is loaded for the first time into a process, and analogously detach when it is to be unloaded from the process. But there are also this thread attach and thread detach entry points, so to say, or calling reasons rather, and they really, each time you create a thread in your process, any DLL will be notified that a thread was created, or when you destroy a thread, that the thread was destroyed. So effectively, you can set up thread-specific states if you want here, and generally, while this can be useful in special cases, mostly actually the main can be ignored. You can just leave it as is, not doing anything, because for example, in our plugin case, what we are more interested in will be some own functions which we export, which then can be called from the project that has loaded the DLL. And one more thing about DLL loading: a DLL can be linked either, so as the name says, it's a dynamically linked library. So of course it can be loaded completely dynamically, so that you have your process, and then it has to call a function to load the DLL, and then it can do something with what it loaded. But there are also DLLs which can be linked with a static library into your project, such that when you start up the project, then the DLLs will be loaded by the operating system loader directly for you, so you don't need to load them explicitly. Like the whole Qt framework is linked this way, and if you even in a non-Qt project look on the libraries which are loaded by the linker, doesn't it display them? It doesn't display them. It's might be annoying. Usually it allows us to view, but it just uses this placeholder, doesn't show us, maybe in the macros. No, it doesn't show us what it loads. We can take a look then on this project here. Here they are at least some, but I'm not sure. Yeah, it's the older versions of Visual Studio showed actually in detail what they were loading. Here we only see what we have loaded. This is the QWT, which is the DLL we compile to plot the thing. So it is also linked in statically. And the way this, the advantages this gives us is that we can really use code from a DLL as if it would be in our project. So we can just instantiate a class with new and do things like that. If we are using the DLL fully dynamically, as we intend to do in our project here, it will be a bit more complicated. So first what we will want to do is we will go to our plugin H and define an own function. So this pre-generated code already gives us some idea how this can work. So we can create a class which can be exported, or we can have functions which are exportable. And here this preprocessor definition specifies, so it can be DLL import or export. The DLL export is the definition you need when you are inside the DLL itself, so that then the function will be marked on the export table of the module, and you would use the DLL import specifier if you would be in the project which imports the thing, so that it knows that it's supposed to look for this in a DLL. In our use case, we will not, I guess, use this part, since we are not statically loading it, but we still need the export thingy on the export set, and we will call it make, how did we call that? Make my implementation. Well, we should find a more generic name, so let's say make either just make implementation, or just we could just call it make object or make plugin. Oh, that's a good name. Let's call it make plugin. And then of course we need and here we do not need the specific. Oh, and of course in type int is wrong, and of course the other of course is we need the right type. So here we can include our interface that was called up. Abstract. Where did we end up with our project? Block one abstract demo. So once, okay, we need to go out twice. Class demo, abstract class demo, interface. Okay, so we have included our interface. Usually in such a scenario we would create either yet another project which would be a statically linked library, or at least some shared folder where we would keep the interfaces together, so that they are in one place, easily referenceable, even if you don't have the main project. Well, actually, since we want to demo that properly, let's do this as well. Copy full path. That was not internet. I wanted to go here. So here we are in this, and then let's create a new folder. Oh, plugin API. Plugin API is a better name. So from here we steal the interface file. Here we can add a folder. We don't need to add a project. We can just add a top-level solution folder. Give it a name and then add existing items. Then it should at some point detect that oh wait, we're in the wrong project. Oops. Too many open windows. Add folder. Interface API. Add existing item. Right, and this thing here should see. Did we copy it? I thought I have moved that. Well, let's just close it. Yeah. We just get rid of this. Okay, let's go back to our DLL. So here we need to change the path to what was it? Plugin API interface. So that's already better. Copy our type. This is the return type of our plugin. Plugin one. Let's pin this. Let's pin that. Okay. And now we can take all that. And in principle we could either do it in an elegant way and put it here, or we just put it there, since this is fine as well. Interface we already have included. So here we just interface. Of course, what we also could do is we could pass here a parameter. Maybe we should do that. Wait, so that we can the parameter is not really defined. No, let's not do that. Generally, if you would need in future some parameters, you could pass them, but since we don't have yet any other interfaces defined, just passing some unspecified pointer is not very useful, so we can leave that as is. Okay, so we should be able to already build a plugin project, this one. And you see also here it created the lib file, which can be used to link something statically, but we don't want to use that. And if we go back here, we can delete the plugin thing, because we don't need that anymore. And here the interface needs to be included from the right location. Plugin API interface. Okay, so now everything is fine, except this one of course will not link, so we will need to load the library. So plugin X is like need to include some more things. Just Windows H for the Windows things like HA module and so on. HA module on the that library thing. We called it. We can can specify either just a file name, then it will look first in the application directory, then on the path in the system variable, or we could specify a full path exactly to where we expect the DLL to be. So it is up to us here, since everything will should be compiled to the same directory. We will not be specifying the path explicitly. Now that said, this is in certain scenarios a potential source of risks, because if you have your DLLs or some DLLs which you want to load, which are not located in your application directory, like all the system DLLs. So when we take a look on any running application, we could start something. Let's comment this out just for a second and just run it so that we have something running. We can comment this out as well, since we don't want too much. We really just want the absolutely minimal binary doing nothing. Where did this go here? Modules, memory, modules. We already see that this loaded quite a few DLLs. So we have the anti-DLL. This one's actually quite safe, as it's preloaded by the Windows kernel, so there really is no way to have here another DLL loaded. But all the other DLLs, so kernel 32, kernel base, and then those DLLs here, they, in principle, if you would put a DLL with this name into the application directory, then it would supersede the instance which is located in your system folder. So here, like this one or those files, if you would create like an own UCRT based DLL or something and put this into the application directory, it would be loaded instead of the original file. Now this behavior can be exploited if you want to modify the behavior of a existing program, and to know which DLL it is using. For example, it will be using the NSI DLL to retrieve MAC addresses of your network card. Then you could put an own dummy DLL in its directory, which would be prepared such that it will return fake values, and then you could change the MAC addresses of your system, at least for what the application is concerned, that's starting this way. Now modern Windows versions have a list of so-called known DLLs. So in this particular case, for example, for kernel 32 or kernel base, this trick is supposed not to work, but there are these DLLs, they're just listed in the registry, so you can modify them, and you can also specify that you want certain DLLs which are known as being system DLLs, which would preferentially be loaded from the syn directory, to just be loaded like any other normal DLL, meaning bypassing the system folder and first looking into the application specific folder, and only if there is and only if it's not found there, then it would be searched for globally. Now, of course, the downside of such hacks is that usually the changes will apply to everything, so all applications will be then vulnerable for this particular DLL to be right. So that's let's open quickly a text edit. So in this location you can exclude individual DLLs from being loaded from the known DLLs list. In this case, I don't remember for which file this is made. It's for NetIP32 DLL. But the way this works is that it ensures that if you put your own NetIP32 DLL in any applications folder, then your will be loaded instead of the system DLL. And of course, if you have other DLLs like all the Qt DLLs, they do not count as known DLLs, so they will always be loaded from first from the application directory, only if they are not found there from other locations. Well, that much to DLL loading. So let's stop this quickly and continue with our example. So we have our DLL. So this what this gives us is a handle to the DLL, but this of course is not yet enough. What we need is the make make plugin function. So we need to use the get procedure address, which takes a handle on the DLL, and then it takes the name of the function we want, and this gives us a pointer. So what we now need is a to define a function pointer of the right type. So this is our original. This we could define in the interface actually. Oops. So this will be our pointer type. Demo. We'll need to cast it, and now we can execute this as a function, and it will return us the defined type, so the my interface, which then here we have, and we are doing something with it. So let's put a few breakpoints. Actually, we could make maybe not just breakpoints, but actually print things to the console. Right, so print so that we see what is happening. Okay, and that's in principle all we need. We can put a breakpoint here. That will be the next interesting thing. So let's run it, and it didn't print anything. Oh, it didn't load so it loaded the DLL, but it didn't find our function. I guess because we did not specify dependency. So we just need to rebuild that thing. Now if you run it, it will work fine. So this still doesn't work, but at least the attached process work. So the problem we had before is that when you press play, it will only build your startup project. So we can go to properties, project dependencies and say that this depends on plugin 1, and now whenever we start this, it will first compile plugin 1. We just need to make sure why this did not work. Function name is correct. I forgot something. Now it builds plugin 1, then we are here and we have our function reference. So this extend_c specifies that basically what we are doing here should just adhere to the normal C standard. And the most important thing is that the function decoration, so how the name gets modified when it gets put into the DLL, will in this particular case be just the name of the function without any prefix, suffix or anything. If we don't do that, the compilers nowadays are for C++ especially, they add some decorations so that you can avoid loading wrong types and things like that to some limited extent at least. But if it's specified as extend_c, then the name is just the name as is. And now we can here just so we can see in our call stack we are still in our exe. And when we enter this, we are jumping into the DLL, which then does its thing. And then the other functions can operate. Well, it printed here test as we expected. We should add some new lines. Where was it? DLL main here. Oops. Okay. Right. And in principle we could so you have here the detach from once the whole program was unloaded, we could once we are done here manually unload it. So we have deleted this. We can then free library. Oops. If we do this, then the order will be replaced because we have our attach test and the hello world is then last, since we actively unload the library before. And we can of course see what would happen if we unload the library somewhere in the middle, and usually this should just cause a crash, and it did because here everything so in this case this pointer, this interface, that the object that we have got here, it contains a jump list to memory addresses, and these memory addresses become of course invalid once we unload the library. So what we could also just for fancies do is put a breakpoint here and then see how exactly this is implemented. So we have some not interesting code, and then set name. Let's run it again. So if the pointer is if the cursor is on the wrong side, we don't do single steps but multiple, but step by line basically, which is not what we want in this case. So as you see, we are going to a jump table which has for set name and for many other things from the DLL, from our DLL jump addresses, and then from there we jump here to the actual implementation. And all of those functions that we have on our interface work the same way. They lead you into a jump table from where you then jump wherever you need. So we could implement the second plugin, let's say plugin 2, which will internally work completely differently, but will still do the same thing outwards. So here 0% Alright, then we can copy a few things. So here, this, and this. Here again, we can comment this out. We don't need that. Plugin one. Should change this to 2, but we don't have to, since it's in a different DLL. It would not conflict either way, but just for demo purposes, let's plugin 2. Implementation 2. And we should probably change the implementation since we added it. So let's go with std vstring name. Oops. So we don't need to delete here anything. Set name is also trivial because there is a constructor from const vchar. The return gets only slightly more complicated. So we have now an implementation which works differently to our other things. So these objects, when cast one on the other, would be completely incompatible. One of the objects contains a CD string, the other one contains just a pointer, so you cannot intermix them, so to say. But when we go to our demo here, we can just load the second DLL instead of the first DLL, and it will not compile. It will crash because we did not define the second DLL as a dependency for the project, so it was not built. Now we have done this. Now it's being built, and now everything works out. Just plugin 1. I should change the name to plugin 2, of course. Yeah, plugin 2. And in principle we could well load all of them. So this is plugin. Let's rename this back to plugin 1. And of course the whole thing could be easily generalized to have our different devices in our other project be located in plugins. Make plugin 1. Can then repeat the whole thing with plugin 2. So this will be implementation 2. And then we delete both of them. 2, and let's call this one just for things of looking nice, more nice if something like this. Okay, and of course free both libraries. Good. Run it. So we see it loaded plugin 1, plugin 2, then they did their job. We should give them different names maybe. To vstring in the whole thing we need the C pointer. C string, okay. I'm missing the L here. So now at least they will print different things, test something and test something else. And what we also could do is we could, once they are loaded here somewhere, create a thread to see the other attach and detach events. Null. Null. That will not be null. Parameter will be null. Creation flag will be null. Thread ID will be null. Oops. and here let's say sleep 100, and here before we terminate we will add before we do this, let's sleep 1000. Alright, this must return something. And here you see both of them reported being attached to a thread and then detached. One thing which is not great is that we don't get like outstanding notifications for the threads which already have been created. So once we are loaded, if we really want to initialize state per thread, then we would need to list all the threads in the current process and then do something to attach to them. But usually I haven't really seen a realistic use case where this thread attachment would really be used when you write your own application. It is used in some cases by some low-level system DLLs, like user32 related to the UI stuff, because then for threads which are set up as UI threads, it might need some additional initialization. But normally there is not a reason why you would need that. The process attach and process detach are more important because they allow you to set up some things and then clean them up before the whole thing gets unloaded. And if you have some inner state in the DLL, then this is of course very important. If you are only using the DLL to call one function that creates objects which lifetime is managed by the calling application. So in our case here, when we go back to our main function, we have to explicitly delete them. So if we would not do that, then the destructors would not be called, and we would end up with a memory leak. So that would not be good. One could of course try to track these objects, and if the DLL gets unloaded, destroy them. But then the problem is that the calling process will not know that the pointers it's probably still holding now are invalid. So we would have the same behavior as we had when we freed the library somewhere here in the middle. So it's not a good idea to track the lifetime of your objects this way. And just dispose them from the DLL. Usually you would really just make it kind of the other way around. You would unload the DLL once the last object has been removed. Okay, any questions? Okay, no questions. Then let's see what else would be interesting. Okay, so one limitation of this approach that we have seen here is that our interface, where is it? Interface is limited to using standard C types, which is not great because they are rather, at least for strings, rather unsafe. So of course this interface could be use their own type, or we could define some other interface that then could be used by the first one. So they are different things. We could and then here we would have the function to avoid something with something that could take a p something and work on it. So such things work, but of course then if you would want to do this with a string, you would need your own string. So this is only mildly, only let's say useful to a limited extent. but generally it would be the way to go. So here, for demo purposes, we could implement our own abstract string wrapper. So the whole idea is that we will not need to do too much about that, because we want this just to be abstract. And what will we need? We will of course need a size t get length. You will need something to then get the string pointer. Get data. We will need something to set the whole thing. So set can just take php data and length, which let's say defaults to -1. Although ideally we would not want that. I would not want default arguments in a abstract class. It should be fine. Should be fine. That will not break anything. Okay, and then of course we will need to create a new string each time. But here, let's say, since we want to create it, we need to create it here and there. Great. That gets complicated quick. That gets complicated very quick. Good. So we have our string. It has a delete, but this will be a different type of interface, since this will be managed by the parent class. So we don't add this. Now we might want to. No, let's keep it. My string, that should be called interface. Let's stay at my string. The other way will be then my string as implementation. Right. So this thing will take now as set name a pointer to our thing, and it will return a string pointer of its own. And this is in as far a complication that we would want to potentially not hold on to the thing that was passed to us. So it will depend, of course, on the semantics, but the semantics of the function could be very easily that the argument is only valid as long as the function executes, and once the function stops executing, it should no longer reference any of the argument values that were passed. So we will need an internal way to make a copy, which is not that difficult. We just call set with get length and get data, but the thing is, we need a way to create such a string inside of our plugin, and that we will not have a implementation for the string, as the implementation is to be provided by the application. So what we'll do now is we'll create a helper struct as make params which will contain we need the first we need this thing here, so my string pmake string, so it will contain a pmake string make string, and this thing will be our argument here, params. Okay, so far so good, and now we need to rework everything step by step. So for starters, we could just disable one of the plugins so that we don't need to do two things in two places at once. I just comment out everything that has nothing to do with this is also not interesting right now. Plugin 2. Okay, so we are now back on it to plugin 1. As you see, it's already complaining that it's missing the initialization parameter, and here we can class my string implementation. Public c main nicht main, my string. And then of course we need to implement everything that's not yet implemented. Okay, so my delete will just delete this. Oops. This is always the same. Get length will do something. This will do something as well, and this will do something as well. Could go with an stdv string, or let's be more again. Let's steal from plugin one. It's implementation. Yeah, that's of course pdata, not pname, and of course this will then also be pdata p. The destruct we will need a constructor and a destructor. That's for later. Oops. Which here just as you might remember, we could here also use the string class we are working in the exercises instead of something simple, but here for this purpose it really is as simple as that we just want to demonstrate the most basic use case. Okay, length, then this will be not length but length, and length question mark. This is length plus 1 plus 1 always comes plus 1 Doppelpunkt. No, that's wrong. That's length and then Doppelpunkt, and this must be not -1. So if uLength is not -1, we take uLength, else we measure the length, and in any case we add one character for the terminating 0. But we don't tell it here, so we add it here, and we copy it here. Or actually we can just copy the thing, it's more elegant, because we don't know if there's a terminating 0, so we actually set at uLength to be 0. Right, so this would be our most basic string implementation. We are missing something. No, we are not. Length, data. We have a constructor here, so we can easily build it, but we will need a function to create those that will then pass string asterisk make string make string did I forget something? Yeah, we forgot everything. That stuff has to be public, otherwise it will not work. Right, so we have here our function makes the string, then we are here what we call this, so we will prepare our params. How did I call that? as make params make string gleich make string. Okay, and then we pass this here as an argument, so the pointer to this thing. And of course it's important here that our params are in turn made up out of something that the other side will understand. And of course, for simplicity here, we went with just a pointer and nothing else. We could add, in principle, of course, more function pointers. We could add, again, machine type, so an array of chars, an array of bytes, whatever we want, from the simple types. And of course, we also could add pointers to more complex types, like we could, for example, here have a string already pre-installed, providing some name or something or other parameters. So the params object is basically constrained by the same constraints as we apply to our interfaces. Yeah, and the next step will of course be now to rework the plugin 1 so that it works with it, and we will rework plugin 2. And I'm thinking that it might be a good exercise to rework this example to use the CX string which we have implemented in the exercises, so that though I think we have one user that does not participate on the exercises, so if we make this a homework, then I would need to add the files from the exercises to this project on Moodle, which I might do. It's not too much work. So, but anyhow, let's now look here. So we have changed the definition, so we need this to be there. Oops. Plugin 1. We define a global variable here to hold the parameters, and such a global variable, well, actually we could so there are two things to consider. First of all, we will be calling this make plugin multiple times. So if we have params which only need to set once, we should either have a separate function, or what we would want to is to store the data on our object, but this seems wasteful. So actually let's improve that slightly. We will introduce a second function that will make it more elegant. So we could of course have the params for a different purpose, but so this will not be make params, but let's call it main API or something. My API is my API, and we'll just make here a second function. Oops, which we need to call first before we can do anything. And this will be called. So it will take this as argument. API, and it will be set API. Yeah, that looks better. That will be more elegant. Let's go here. So this will need to be changed. So we will call this my API, and we will put this globally here, because the definition will be that this remains valid indefinitely, so that it only becomes invalid when the whole application gets terminated. So here, before we make plugin, we need the other one. So set API, set API 1, set API, set API, and we call set API 1 with a reference to our thingy. Okay, so then we go again to plugin 1. We have now two functions. Yeah, let's keep it here. This one has a void. It doesn't need to return anything. You can copy this much. Set API. Okay. And let's define it here. This is not needed, and we'll have a okay. API. How did we call it here? I think we called it my API. Let's call it only API. No, let's stick with my. One thing that's different is here that we'll have a pointer. So in this case, we'll assume that, as mentioned, that this will live forever. So we don't need to make a copy of the content. We just save the pointer, and that's it. This will need to be reworked next. So we copy the two new definitions. Okay. Internally we can hold it in any way we want in principle, so we could still keep it as this thing. Actually, maybe this is not the worst demonstration. Let's keep that intermittently, because we'll just reuse a portion of it. So we go into the set thingy. Now we know that we have a fixed name, fixed length, so we can just the IntelliSense is not working. The IntelliSense is not working. Okay. One. It's included. Okay, it just didn't update the preview. Okay, name +1. Here we know that it's not terminated, so we can do that, and then here get data. Okay, and the return will need to construct such a thingy. So we can delete those things. We don't need that. So we will need to use GAPI make string set my name and return name. Okay, so we are returning the name. That should be working already. Should be fine. Almost. Here we are still not using the right new mechanism. So print name. Let's first have set name and then print name. So set name will need a name. So in principle, since we are here outside of the whole thing, we don't necessarily need to use our make string function. We could just it's fine. We don't, since here we have access to it, we can use it. So it saves us on a few lines of code. Set const. And in the interface. Right here. So this works. So here we just need to set it, and as we said, we say we need to delete it since it's our responsibility. We could in principle have this defined such that set name will need to call the we'll need to call the delete me function. Usually this thing is also called like often release or free, but since Qt is using the delete later, to delete later, I thought using here delete me is a good name. Yeah, so here of course then we will need to semi-string paste op name to be consistent. Get data, and so obviously you see here it's not, and here since it was made by the other one, let's go with delete me. Actually, the way this thing is implemented, we do not rely on what getNew returns actually being our own implementation. So we could here make yet another implementation of the string, and this would still work. We would not need to use this one, which we might do in a second if we want. So as you see, using these abstract interfaces gives us a huge flexibility with regard to which objects we are using and how we can combine things together. Of course, just returning the one pointer and is more efficient. So there is a reason why in the past people did everything with C strings, and it simply is a nice thing performance-wise. But if you really need to avoid security exploits and other bugs, your program's crashing, etc., then everything where you are using raw arrays is just a potential source of issues. So using complex objects, even if it means copying memory around a few times more than it would be otherwise necessary, is a price worth paying for the avoidance of potential security and reliability issues. The main problem here also with memory corruption is that if you have a release build which is highly optimized, if you have a release build which is highly optimized and you introduce some memory corruption to the application, that you are very likely to have some very strange crash in a very strange place, which is completely unrelated to where the actual issue initially originated. So such a bug is very, very hard to debug and to trace. So yeah. Right, so we have this. Then we should of course now change the second. First of all, we should see if it works. That's the most important thing. And then I didn't, so we broke something. Data length is 7. Data. Oh yes. That is very bad. Yeah, you see, I was talking about memory corruption. We already run into some. So let's see what's wrong. So we have length 7 with 1. It should be 8. So we should have 8 characters space. Where does the crash come from? It comes from let's see, load symbols. But it looks like this save thingy does not like doesn't like it. So that should be enough. Oh wait, p data, length, data. And is that really 7? Looks like it's 7 characters. Yeah, it's 7 characters. Let's put a breakpoint here, and because before it worked fine, so there is something we are missing. So we have our empty array of characters. That should be enough space. We have our link was already made, so this u data is 7 and p data is data somehow buffer too small. Oh right, we need to tell it the right size of the buffer, of course. So the idea is that length only holds the actual length without the terminating null, but here for string copy, yeah, if you would use memcopy, it would be fine. If you are using string copy, it insists on adding the terminating null, so the length must be long enough to contain also the terminating null, so we can skip the manual adding, and as you see, it works fine. So next thing to do will be to enable the second plugin and fix it such that it is working as well with the new interface specification. So let's see, plugin 2. Let's speed it also. So from here we just take this one function, but we need to remember to change the definition here. Then copy this. Right, and here for plugin 2 we could implement it differently with its own string type, for example. So we will actually not use this parameter at all. Plugin 1. Let's go to interface. Those two thingies here, and we will make our own string class for here. My implementation, and we are lazy, so here we will just make a value. So we don't need anything in the destruct one. Delete this is important. Length is just punct length. Data is just punct cstring. Set is just the sign. It has point and count. Okay, it's not perfect, but it's good enough. So data, comma, was it here? No, it was and that's a much simpler implementation, much more convenient, much less efficient. But we should give it a different name. My string std, or my std string, my standard string. The same name would not be a problem because it's a different DLL, but just to when you're using the debugger to easier be able to tell those things apart, it's good to use different names. Right here, and now why is that complaining? Make plugin, make interface. We forgot something. Alright, those two functions we forgot to implement. So name is assign get data, get length, and here we make our own string, pass like new string, and what we can do is we can make an own set function, one that is only for us, it will not be available anywhere else, and one that takes just a std string and value is equals value. That simplifies the work for us. So pair string set name, capital N. Yo. So let's enable this. Now, since we know that we are not using the this one we don't care for. That's a boring test case. Now, since we know that we're actually not using the API, we could, in principle, not set it, but that would be bad practice, since normally the idea is that you don't know how your plugin is implemented. Oops. Yeah. Meaning that if the specification says that you have to call set API and provided a means to generate your external string, then you have to do it. Even if you would know for a certain plugin that it doesn't use it, it's good practice to just adhere to the specification, because at some point, for example, the plugin might be changed by its author, so that now it needs it, and if you have not been setting this before because you thought, oh, right now it's not necessary, then this will break. Of course, one thing that is apparent here is that all these design patterns are really intended to facilitate interoperability and collaboration between different developers. So if you have like one project on which you are only working, then you could have everything linked statically, or mostly statically, like the QWT library, and not care for these mechanisms. But then your application won't be able to work in one big chunk, and you won't be able to, for example, if you would want to distribute your application to multiple users and not only use in your lab, but put it on GitHub such that other experimentalists or theoreticians can use it for something, then effectively they would need, if they want to customize it, to always, even if they just add one simple plugin, they would always need to rebuild everything, because they would never know when you change something if it won't break their own plugin. But if you adhere to such a design strategy, then they can just take your binaries that you compiled once and put on GitHub, and then they only compile their individual plugins, and they can rely on those plugins remaining functional even with newer versions. And ideally, with such interfaces, you would try, when you go to when you improve things, when you change things, to not break the existing interfaces. You can add new functions. This is, for example, why on Windows there are a lot of functions which are suffixed with X, like extended, because they were many like open key, open file, etc. And then they thought, okay, we need more parameters, so they made the open file extended, open key extended, etc. And unfortunately, later on they just went to open extended 2, 3, and 4, so they are not being creative with new API versions in that sense. But this is something that need to be taken into account. So you should never change in your interface once it has been released. For example, here the arguments. Again, now we change them because we are still in the initial development phase, so we can do what we want. But once it's public, if you would want to have a set name which takes a my string instead of a C string, a normal C string, then you would need to call the new one set name X or set name 2, and keep the old one for compatibility. Of course, if you make like one big major new release, like from, I don't know, version 1 to version 2, for example, you could say, okay, version 2 requires all plugins to be rebuilt. There are new APIs. That is fair. But as long as you just make minor changes, even if you add new functions or add new arguments, you should always do it in a way that it will not break the existing interface. Right, so we can run it and see if our other string works as well. And we can put a breakpoint here just because it's interesting. Okay, so we have done one thing, and here when we go in, we end up in our own delete string routine. When we continue, and then we have the other invocation, then we will end up in the delete me of the plugin, since the plugin 2 decided to use its own string interface instead. And as you see, it works just fine without crashing. It prints everything as expected. So yeah, so this design pattern is really useful. and very, very flexible. So the next improvement, of course, would be not to use pointers at all, but use some sort of self-made smart pointer. This is a bit more tricky because there you would have to have at least some implementation shared. So if you would want to do such a thing, and then what would be, for example, an option would be to have a shared library, which then your project is using and the plugins are using, and all the objects, the more complex objects from that shared library, which then could be linked either fully statically or semi-statically using a lib file, but still using functions located in a DLL. But then, of course, this library would not need to change unless you want to break the compatibility. So there is a whole rat's nest, so to say, of things. Well, one approach that can be used here to improve on this is to use on the side of the pointer user some smart types which will do the cleanup for you. So we could implement this as well. As you see, we always, whenever, in this case it's just here, but whenever we do something, we need to call this delete once we are done with it. So it would be very convenient if this could be done for us. And I'm very tempted to put it into the interface class, even though it technically is not an interface. Then let's not do it, because that would be bad practice, or rather a bad example. So let's instead create a helpers header or something like that. That's annoying. Then Windows 11 does not offer you to create anything. We'll just copy this and then delete the content. Add existing project. Not existing project, existing item. Plugin API helpers. Okay. Here we will include that. And what want to say class? It's my pointer. And since this thing, since we want the whole thing to be somewhat convenient, the thing will have to be a template. We could, in principle, implement it like introduce an intermediate interface, like something that from which my string and my interface and everything is derived, which only contains this delete. But the downside of doing this would be that while this gives us the ability to create a pointer, a smart pointer object which works for any type and only needs one implementation, whenever I would want to access any of these functions, we would need to do some typecasting, which would be unelegant. So instead we'll just create a template helper class. Okay, and the thing will take t asterisk pointer, so it takes something that we have. T asterisk ptr. So this is just assigned, and when we destroy it, it should check if this is not null, because it might be null for whatever reason. And if it is not null, delete capital B. Oops. Right, and what do we need now? T asterisk. Was it asterisk or was it? I don't remember. We can have an error operator which should just return mptr. I think it has TSA return type. Then we would want to have a T reference and return ptr. in principle those are const because they don't yeah, because they don't allow us to change the PTR, but in that sense the pointer which they give us back is still of a non-const type. That is the should be the absolute minimum. Like we could also add a function like to check whether the pointer is not null. Actually, we should do that. For operator and PTR and we can add things as we go along. So helper is included. So here see my PTR of type CString, and here it is already smart enough to convert it the proper way. This here does so the delete we don't need in either case, but here it's complaining because we forgot to add one thing to our my pointer, and automatic conversion. Wait, this one isn't right. Was it just called vol? Yeah. T asterisk T. I think something like that should do the trick. No, I don't remember the right syntax. One moment, please. I have to look that up. This is the exclamation mark. Okay, so the first one, since the name already is the type, you don't need to specify the type again, and it will be the same case for the other one. The asterisk okay, so now here we will put a lot of breakpoints everywhere so that we can trace how this thing works. Right, and here we can do the same thing. And we'll put a breakpoint here. Now the second one is not interesting. So we end up. So first we construct our string, then we assign it here. Then we enter here this operator which just returns us the actual pointer, on which we then can do our set. And then here we end up in this operator which gives us again a pointer out, so that the pointer can be passed directly to the set function in the plugin, which internally handles just a normal non-smart pointer type of thing. So there we can go get out, and then when we continue we end up in the destructor which then calls the delete me, which brings us to the right delete me, and the other case will do the same thing. So using such a helper class is already a great improvement with regard to reliability, because it ensures that we will not forget to deallocate this memory, and since it's somewhat automated, it also ensures that we will not end up deallocating it too early before we are done using it. Now the way this particular pointer was implemented is a bit dangerous, because what you can do, which would be a bit of a catastrophe is we can do this, and effectively as soon as we get out of scope here, this thing will be deleted and the rest will crash. We can quickly take a look that it will. Yeah. So what one would want is to prevent such things. Obviously, there are two ways to prevent it, and usually typical smart pointers actually employ both methods. One method is to make the constructor explicit. And the second thing is not to provide such a function. So first we can see what this explicit thing does for us. So here first thing is we cannot do this, but we really need to make it like this. But then we are missing the assignment operator. So right, we can do it like this. That should be fine. Because that's the same. How it should. Did I mistype that? Oh, it's without the E. Right, so that should be fine. But here, unfortunately, it's still allowing the assignment, which in this case we would not want. So what we can do is we can private pointer reference is equals const reference pointer. No, that will not work. We can provide the empty body. Since it's private, it cannot be called from the outside anyways. It's still accepting it. We don't want that, so we'll also add a not reachable copy constructor. Okay, now we have what one. So we can no longer assign it. So this already gives us the safety that we cannot make a bug like this. And at this level, the way this works is we can still. So here again, you see it's not allowing us to do that. But what we can do here is it still gets automatically casted on a normal pointer. Here, of course, this needs to be changed this way. This is somewhat good enough because usually you will not want to initialize this like more than once. There might be, of course, use cases where you want this to behave differently, so then you would need to design the whole thing in a different way. So, for example, you might want to be able to actually save the pointer and not delete it, so then you could add a detach function. So something that allows you to get the pointer and bypass the automatic deletion. So it would be test asterisk detach t asterisk ptr is like m underscore ptr, m underscore ptr is like null ptr, and tone ptr. So we make a copy of the pointer, we set it to null, and then we return the copy, and at this point the pointer can no longer be deleted by our smart pointer. Yeah, anything else? Yeah, and in principle that is mostly it with regard to those things. Any questions? Okay. Since we have only very little time left, I don't think we can start something new, so let's see if we can demonstrate anything else here. I think not really. We already have a quite comprehensive demo. We have smart pointers. Well, we could of course try to improve the smart pointer such that we can have multiple instances of it. That makes the smart pointer more complicated, but also more powerful. We can try how far we go. Okay, so we start with the same thing, but there will be changes. So those things we will actually need to work. Those things will need to work. This needs to remain explicit. This is, we'll leave this one for now. Detach must go. And the main problem is that we need to somehow track how many objects, how many pointers are keeping a reference on our object. So we will need some sort of helper class. So as my ptr t gen ptr just pointer, then some counter, and this should be things from star. The counter should be made such that it will not that is in a way that it will be that it will be a thread safe. So what we will want to do is we will want to, what was it? Let's take a look what the function. What was the right type for that? Exchange takes volatile unsigned long. Or do we have other? Interlocked add 16. That takes short. That could be good enough, because I mean we don't expect more than a few thousand instances of our pointer, although that is a bit short. But we only have the normal version, which takes already a long, so a 64-bit. It also takes long, that's fine. Then let's go with volatile long. Volatile long ref pointer. Volatile for pointer. Okay. So this will be ptr will be of this type, and this must be of course stalked. Yeah, you can do this to save lines, but this is more elegant like this. Okay, so when we are creating it here, then and this will not be ptr but just m is equals new yeah, we don't want this to function across. The next level of complexity would be to make this such that it actually works across boundaries of our modules, but that will be something for later. So we just create a new m ptr is gleich pointer, ref is gleich 1, because there is one reference. This thing, right, then we need internally a few helper functions. Attach Stern and detach. Detach and attach now are doing different things than they did before. Okay, so a detach just means, or maybe before we could also call it href and the reference. Right, so the destructor checks if it just always makes dereferencing. The copy constructor just calls addref with add m. The copy constructor does the same. It just returns asterisk this. This would need to be changed to mptr. Oops. mptr. Here and there, and here and here. Although m and Fragezeichen null or ptr. Here it should be m question mark m doppelpunkt. And this one, well, this will not be good. Because here we cannot return. Well, we should throw an exception basically at this point. But let's just remove that, and that's it. We're not using it anyways. Okay, so let's see if this looks safe. We create this thing, we make attach and so we make addref and deref. We make addref again. Here we access if it can be accessed, whatever this is. This could be null, we don't care. Here we check whether it is, and then this is not null. This is fine. Here we just return this on repeater. That looks all correct. Now those two functions need to get some implementation. So deref is just checking if m exists. So if no m, then just return, because then it doesn't have anything to do. Addref will always do deref first. I mean, it would maybe be a bit of optimization if we don't do this check, but move the check here and then have another copy of the check there. But this is, I think, more foolproof of an approach. And we start with this addref option. So we have the reference to what we already have. So at this point, we know that everything is empty. So we make m is equals p. And interlocad add m reference comma 1. So we are incrementing it by 1. The order here does not matter. And here now, that's the more interesting thing. What was it? Interlocad reverse subtract. And we can usually just add with a negative number add. And if I recall correctly, it will return. I need to check the documentation. It either returns the value that it ended up, or it returns the value that it had before it was done return. Returns the result of the operation. So what we want to do here is to our ref add -1, so we decrement it by 1, and if it returns the result of the operation, then if this was null, sorry, if this was 1, then now the result is 0. So if this is 0, then we can delete everything. So we already know that m exists, so m ptr if mptr, then not delete, then it was delete me, and then we can delete m, and m is and set m in any case, m is equals null ptr. So if we enter this function from two threads, this interlocked add will ensure that one thread will get as a result of the so we are entering in two threads, so at this point there are two copies of the pointer, and when we enter this, then when each of them does its subtracting by one, since we are using an atomic operation, this interlocked functions are implemented with individual CPU instructions, which on the hardware level guarantee that they will not be interrupted by any scheduler preemption. So even if they would need multiple cycles to execute, or there would be some data in some caches, then it is still guaranteed that the memory state system-wide will be consistent. So even if two threads enter more on two CPUs at the very same time and try to do the same operation on this memory block, one of the operations will return the 0 and the other one will return 1. If you would just use -1 and then looking up what's the result, then it could be that both at the same time do the subtract and both see 0, and then you would call delete me twice, which would be of course not good, since this is now hardware-wise guaranteed to be not interruptible in that sense. So the result which we will obtain will be the result of this operation, and one of the operations will be just delayed until the other one is completed. So with this, we have now a pointer which should survive our our test case. And this was so if we do something like this, it should still be fine. So we can put a breakpoint here and run it. We have some that should be a dot, and here as well. Okay, so we can ignore the decompile for now. So we enter the thing, we enter here addref. We first deref which returns because there is nothing, since we are a new instance. And then we increment it by 1, so this should be now 2, and it is 2. And then the next, and then we are done with the constructor. And then of course the next step will be just directly the destructor. So we enter here, we see that we have something, this thing is 2. And since the result of the operation was 1, we have not executed this, we just set it to null, and we are done. Then we of course do the same thing we did before. This works as well. This enters here, and then there, so this works fine as well. And then when we continue, we end up in the other destructor, which now will call the delete me at the right object, and then return out of everything completely. Zack. Et voila. Okay. I don't think that we can manage in the last 7 minutes to improve that even further. The problem here is that this pointer, maybe we can, that would add another level of complication to the whole thing, because the way this thing works is that it needs to do its own delete and new for this helper object, which is holding the status, plus the pointer itself must be made such that it will be passed across the module boundaries So I think that would complicate things too much if we try to improve this even more. It's generally should be just enough to know that on the interface you have just you can delete this here. On the interface you just have normal pointers, and then you need to wrap them in a guarding object as soon as you get them. And another design pattern to actually improve on this would be here to not use those functions where is it here? Those functions on the plugin in your code everywhere directly, but instead have some wrapper function that you call, which always does the wrapping for you. So in this case, this is not a problem because we need to create a string as already, but here we are receiving something and we don't have the guarantee that it will behave the way it should behave. What we could do, there is one thing we could do, is we could create an abstract receiver class, so that if you want to return a value, you are not passing, you are not using the return value of the function actually, but you are passing an argument of something with a given interface on which a pointer can be set, and then you can guarantee that someone will not accidentally forget to use that. But as mentioned, that would be a few more changes. So if you are interested in that, we can continue on the next lecture, improving our smart pointer. Because at this point it will of course be convenient to define, at least to some extent, a pointer abstraction such that we can pass our smart pointers across the module boundaries, and this should work reasonably nicely, except for that we cannot use it as a return value, but this is not a large limitation. Any questions? Okay, if there are no questions, then I guess we are done for today. Next week we will continue improving this using the objects, the passing pointers to, or at least a pointer interface to our other plugins, and we maybe also take a look at in Qt on some design patterns regarding to separation of UI and backend data. Currently in our demo project we have been just using the Q3 view, Q3 widget. What was it? GUI panel data, which generally is quite a convenient thing, but since we need to use this at top level item and then add item and so on and so on, if we would have a huge data set with very many elements, especially if they often change. So if we just create it once and then keep it, then the thing is good enough. But if we would have something that can change quite often, then it would be a large optimization to use a custom model and a Q3 widget view, which then would dynamically load the data from our model, such that we don't need to always copy everything, but really only need to notify about data changes, and then only then the data actually displayed and updated if they are within the view that the user sees. So if you have a very long list and you just scroll to some point, only the small visible section of the data will actually be updated using this view model programming pattern. Okay, yeah, I think if we can end now. We have only 3 minutes left, so there isn't much that I can tell you in 3 minutes if we would need to start something new. There will not be any homework, since I don't think that this would be enough of a challenge, because we already have seen how to implement yet another string, and just generalizing this to yet another string is kind of boring, so as mentioned, there will be no homework this time. But you can of course take a look through it, maybe try for fun to implementing an own plugin which does something other differently. Yeah, and that's that. So have a nice weekend, and we'll see each other in a week. Bye bye.